Welcome to Basic Physics. This application will discuss about the basic fundamentals of physics. This application contains 16 main chapters, focusing on 50% of understanding the academic content, 30% of additional knowledge, and another 20% on calculation. There are explanations with pictures and narrations with interesting content to make a difference to studying in the classroom, as there are so forces and Newton's laws of motion. Before getting into Newton's laws of motion, let's first get to know about the scientist named Newton. Sir Isaac Newton was an Englishman who lived during 1643 to 1727. He passed away at the age of 84. He was widely recognized as a physicist, mathematician, astronomer, philosopher, and technically an alchemist. Newton wrote many books with important contents such as prism refraction, the law of universal gravitation, classical mechanics, laws of motion, and calculus. In this chapter, we will focus on the principles of mechanics using Newton's 3 laws of motion to explain. Before we start Newton's 3 laws of motion, we'll go back to 384 BC, more than 2,000 years before Newton was born, to talk about the great Greek philosopher Aristotle. Aristotle was the founder of scientific knowledge. Alexander the Great. His writings include the subject of anatomy, astronomy, poetry, zoology, politics, government ethics, biology, and physics. In physics, Aristotle described motion in which objects require force to make them move. If no force, then the object would stop, and heavier objects fall faster than lighter objects. 1800 years after the time of Aristotle was the time of Galileo Galilei, an Italian scientist. In the time of Aristotle, people believed that the Earth was at the center of the universe. The Sun, Moon, and other planets revolved around the Earth. Galileo explained by using telescopes to observe the motion of the stars and concluded that the Sun was the center of the universe. Free fall is the motion in a vertical position by a gravitational force. First of all, let's review the 4 formulas of motions, which include equation number 1, V equals U plus AT. Equation number 2, F equals V plus U times T over 2. Equation number 3, F equals UT plus half AT2. Equation number 4, V squared equals U squared plus 2AS. After reviewing the 4 formulas, we'll determine the direction or reference point. Here, we'll refer that where the object starts moving, that point is the reference point. In the previous topic, we studied free fall motion. In this part, we'll discuss about the movement of both the x and y axis. An object that is acted by more than 2 forces and more than 2 directions makes the object move in a curved line, or we call projectile motion. To calculate projectile motion, 1. The initial velocity is not 0, because